today we'll be learning rules of differentiation. And it's important that you understand the rules of differentiation, because this is what's going to help you to solve any differential equation you're given to if you understand the rules of differentiation. And quickly in this course, in this video, I'm going to run through about 7 different rules of differentiation, and I'm going to give you some work examples. We're going to work some questions out in course of trying to explain each of these rules of differentiation. Alright, so the first rule of differentiation we want to talk about is the power function. The power function is just states that if you're given a function, say, states that x to the power of n is equal to nx raised to the power of n minus 1. That is to say, if you're given a function to the power, the nth power, example, you are asked to differentiate the function to x squared, or let's say to x cubed. In this function, here let's say y is equal to 2x cubed. This function, the power 3 is Rn, and the function 2x is the value of x. So differentiating this simply means that 2 the y over the x, y over the x is equal to, when you differentiate 2x cubed, you're going to have the power n, which is 3, is going to multiply 2x, and then the power 3 again is going to be 3 minus 1, and this is going to give you 3 times 2, that is 6x, and then 3 minus 1, that is 2. So that becomes the answer. It's going to be 6x squared. Solve another worked example. You're given still on the power function. Let's say example 2. Y is equal to 4x to differentiate this is just going to be power 2 is going to multiply 4x raised to the power of 2 minus 1, and that's going to be 4 times 2 times 4, that is 8, and then x 2 minus 1, that is 1, which is the same thing as saying 8x. Whenever you're given a function like this, just use the power to multiply the function and subtract 1 from the power. As simple as that. Let's work another example, a third example. We have y is equal to the square root of x, and you're asked to differentiate. So if you differentiate the y over the x, it's simply saying differentiate the square root of x. And this is the same thing as saying that if you want to differentiate that, this is going to be, you can rewrite this as to the x 1 over 2. Because I know my rules, my rule of sorts that says that if I have to the square root of n, the nth root of m is equal to m to the power of 1 over n. So that was how I was able to apply this rule to get x to the power of half. So moving forward, if I apply that rule and I was able to transform the square root of x to the power of half, and then simplifying that further using the power function rule of differentiation, which states that if I have x to the power of n is equal to n x n minus 1. Therefore, if I'm to differentiate this now becomes that becomes 1 over 2 multiplied by x to the power of 1 over 2 minus 1. And this is the same thing as saying 1 over 2 x, and that's going to give us minus 1 over 2, because 1 over 2 minus 1 is minus 1 over 2. And I can further rewrite this as saying this is going to be x over 2 to the power of minus 1 over 2. Same thing as saying 1 over 2 square root of x. Again, how did I get 1 over 2 to the square root of x? In case you're wondering, I'm still going to apply the rule of sorts, which I explained earlier than now, that if you have a question like this, okay, if you have the square root of, let's put it this way, if you have, rule says that if you have m to the power of minus n is equal to 1 over m to the power of n. X minus 1 over 2 is the same thing as saying 1 over x to the power of 1 over 2. And recall, you know what 1 over 2 is? 1 over 2 is the same thing as saying, you can rewrite this as saying 1 over the square root of x. Which is the same thing as saying, so if I can rewrite this as this is the same thing as saying x minus 1 over 2 is the same thing as saying 1 over 2 multiplied by x minus 1 over 2. This is the same thing as saying 1 over 2 multiplied by x minus 1 over 2 is the same thing as saying 1 over the square root of x, which is equal to 1 times 1 is 1, and then 2 times root x is 2 root x. So that was how I was able to transform that to this. Right, so moving forward, let's forge ahead to the second rule of differentiation, which is called the scalar multiple rule. In the scalar multiple rule, if I have k, which is a constant, if k is a constant value, and we have the function f of x, then if this is true, then we differentiate this function, a constant k, and a function. This is going to be k. What this simply means is saying, if you have a constant with a function, you bring out the constant and then differentiate the function. So you're going to use the constant to now multiply the function. After you differentiate the function, use the constant to multiply whatever you get as your answer of differentiating the function. Quick example is going to be this. So let's solve just one or two examples to buttress the point. Example, you have if y is equal to 7x 4 raised to the power of 4 minus 20. Okay, let's say this is 21. X squared plus 14. If I want to differentiate this, the y, differentiating y with respect to x is going to be, first thing first, I'm going to bring out my constant, which is 7, and then I'm going to differentiate x raised to the power of 4. X to the power of 4 minus, I'm going to bring out my constant, 21, and then I'm going to differentiate x to the power of 2 plus 14. So I'm going to just differentiate 14. That being said, so the y over the x is equal to 7 multiplied by differentiating x to the power of 4, and that's going to, using the power function, x to the power of 4 is going to be what? 4x to the power of 3 minus 21 multiplied by differentiating x to the power of 2, it's going to be 2x to the power of 1 plus differentiating a constant is 0. So whenever you differentiate a constant, the value becomes 0. So multiplying this through, this gives me 7 multiplied by 4x cubed, that's going to be 28 x cubed minus 21 multiplied by 2x, that's going to be 42x plus 0. So this becomes my final answer to that question. So the scalar multiple function says whenever you have a function with a constant, all you just need to do is to multiply, use the constant to multiply the function, differentiate the function, and then use the constant to multiply whatever you get by differentiating the function. Right, let's go to the third rule of differentiation. So whenever you have a function that's adding itself up or subtracting itself up, how do you differentiate it? For example, if you have a function like this, this is a function f of x plus or minus, you have another function g of x, and then you have another function plus or minus, you have another function, let's call it h of x. What this simply means is you have to differentiate each function individually and then retain the sign. So this simply means d over dx, f of x plus or minus d over dx, g of x plus or minus d over dx, and then h of x. This is what the addition subtraction rule states. So what this simply means is differentiate the function f of x. When you differentiate it, you retain the sign, you differentiate the function g of x and also retain the sign, and then differentiate the function h of x, also keeping the sign. Let's solve an example question to buttress the point. So example, we're asked to differentiate let's have differentiate a function. Let's give a question 3x is minus 1 over 2x squared plus 4 over square root of x plus 5. And I'd ask to differentiate with respect to x. Okay, if you understood the addition subtraction rule I just dished out, explain what I just, if you understood what I just explained, how you're going to approach this question becomes so easy for you. So to solve this solution, we have to, this is a function, we call this function, this is f of x, this is another function, g of x, this is another function, h of x, this is another function, I of x, this is another function, I. Okay, so using the addition subtraction rule, we have to differentiate each of the function individually and then retain the sign in between. Okay, so to do that, quickly we're just going to then say that differentiating x to the power of 4 minus differentiating 1 over 2x squared plus differentiating 4 over the square root of x, and also differentiating constant 5. Remember, when we differentiate the constant, you have 0. Get back to that. Okay, so differentiating this function, the first one, 3x to the power of 4, that's going to make me to apply the power function rule. That's going to be 4 multiplied by 3x 4 minus 1 minus, if I differentiate this second function differentiating it gives me, I can rewrite this as saying, I can rewrite that function as 1 over 2 multiplied by x to the power of minus 2. For our law of indices, if we have 1 over a is the same thing as a raised to the power of minus 1. So if I have 1 over 2 multiplied by 1 over x squared, because that's what this is. 1 over 2 multiplied by 1 over x squared is what this is. Okay, so if I have this, this becomes 1 over 2 multiplied by, using this rule, this now turns to x to the power of minus 2 because of a power 2 here. This is to the power of 1, but we don't need to write 1 there, that's because we already know that's 1 there. But let me just write it for reference sake. So if here was 2, here becomes 2. Alright, so this now gives you x minus 2 over 2. Now you understood how I arrived at this. And then plus, if we differentiate 4 over x squared, the same rule applies there. This is just going to give us 4 multiplied by, follow the same rule, multiplied by minus 1 over 2 plus, and if I differentiate the constant, okay, I'm not differentiating yet, I've not differentiated yet, so I need to put my differential sign. So I'm just transforming it. Not differentiated yet, so I still need to put my d over the x. This is giving me 4 times x to the power of minus 1 over 2 plus, this is just going to be plus 0, because if I just differentiate the constant 5, I'm just going to get plus 0. So this is, I'm going to have 12x to the power of 3 minus, when you differentiate this, let me just work it out here for you to show you. I want to differentiate 1 over 2 multiplied by x to the power of minus 2. First of all, I have to just differentiate only this. This is a constant, and keep that. If I differentiate this, this is going to give me this is going to give me 1 over 2 multiplied by, this is going to be minus 2 multiplied by x to the power of minus 2 minus 1. That's going to give me 1 over 2 multiplied by minus 2x to the power of minus 3. And that's going to give me 1 over 2 minus 1 over 2, 2x to the power of minus 3. 2 go here, can go out, and that will be left with minus x to the power of minus 3. So what I'm going to have here now is going to be what? Minus x to the power of minus 3. Plus, I'm going to differentiate this other one. So if I differentiate that, I'm going to have minus 2x to the power of minus 3 over 2. The same approach, the same thing I just did here, I'm also going to do it here for you so that you understand and we are not doing some manipulation here. Okay, so I want to differentiate 4 x to the power of minus 1 over 2. So this is going to give me, this is minus 1 over 2 multiplied by 4 multiplied by x to the power of minus 1 over 2 minus 1. Remember, you're keeping the 4 constant. Keeping the 4 constant and multiplying the power minus 1 over 2 multiplied by x, and then you all raise it to minus 1 over 2 minus 1. Okay, so this is going to give you 4 multiplied by 1 over minus 1 over 2 x minus 1 over 2 minus 1. That's half minus 1. It's going to give you minus 3 over 2. Two can go into this one, 2 can go into here, that's 2 times, so I'm left with 2 into minus x minus 3 over 2, which is the same thing I just said, minus 2x to the power of minus 3 over 2. Right, so see how I arrived at this. Minus 2x to the power of minus 3 over 2. Okay, so moving forward, we already know this is plus 0. And this is going to give us 12x. Can rewrite that to the power of 3. Minus, this minus, multiplying this minus, opening the bracket turns to plus x to the power of minus 3. This positive sign multiplying this negative sign turns to negative 2x to the power of minus 3 over 2. And of course, plus 0, that doesn't mean anything. So I can rewrite this as saying 12x to the power of 3 plus 1 over x cubed minus 2 over the square root of x cubed. And that becomes my final answer. So you could see how we were able to use the addition and subtraction rule. Pretty easy, just understand, use the flow of algebra, and know your laws of indices, laws of logarithm, and you're good to go. So the next rule we are going to be looking at is called the product rule. The name speaks for itself, product rule. Whenever you hear the word product in mathematics, what it's simply saying is just using multiplication. So that simply says that two functions are multiplying each other. Have a situation where two functions are multiplying themselves. Best approach to solving that question is using the product rule. And the product rule just simply states that we have the function this is equal to u, the v, this is letter u, the v over the x, plus v du over the x. So a pretty way I tell my students to always use to memorize or to remember this formula is looking at the English alphabet. U comes before v, so I'll say u, and now I've written u. The next thing I will do is to look for the differential of the next function, the v over the x. So since I've written u, the next what is going to be is not going to be u du again. Du and u cannot be together. That's just how I teach students to use to remember this, because sometimes students make a mistake to say this du over the x plus v dv over the x. This is wrong. So the best way for that not to confuse you rather, the first letter u and then what comes next cannot be u again, so it's going to be v plus, and then next one is v. So what comes here cannot be v again. So since I have v here, what comes here cannot be v again, so it's going to be du over the x. So with this, you can easily remember this and you won't be confusing yourself with this. All right, so why this is correct, this is wrong. So that's what the product rule states, that if you have two functions multiplying each other, it's just the product of u, the v over the x, plus v du over the x. So we have a question here we can just pretty solve real quick, and just want to make it really simple. Just a simple question. Okay, let's say we have a function example. If we have the function we ask to differentiate function 3x minus 4 into, and you have another function 4x plus x. I know I'm going to use my product rule to differentiate this, so using my product rule, this is going to be my u. This is the first function u. This is the second function v. Break out what the product rule states. I can say that u is equal to 3x minus 4. Therefore, I need to get du over the x so that I can substitute it into my equation, my formula. So du over the x is going to be 3 minus 0, that is 3. Is differentiating a constant is going to give you, let's differentiate 3x. This is 3x means 3x raised to the power of 1, so that's 1 times 3 multiplied by x raised to the power of 1 minus 1. So 1 times 3 is 3 times x raised to the power of 1 minus 1 is 0. And in mathematics, anything raised to the power of 0 is 1. So this becomes 3 times 1. And that becomes 3. Okay, and then the next thing we have to look out for is to differentiate. Okay, let's know what our v is. Our v is equal to 4x plus 2x. Therefore, the v over the x is equal to, it's going to be 4 plus 2, and that is 6. So if I differentiate 4x, I'm going to have 4. And I differentiate 2x, I'm going to have 2. So 4 plus 2 is 6. All right, so moving forward, we put that into the equation of this. Recall it's equal to what? U the v over the x plus v the u over the x. And this simply means that our u is what? 3x minus 4 multiplied by our the v over the x is 6 plus, what's our v? Our v is 4x plus 2x. And what's our du over the x? Our du over the x is 3. So this becomes 6 multiplied by 3x minus 4. So 6 multiplied by 3x is going to give you, that's going to give you 18x multiplied by 6 multiplied by 4 is going to give us 24. Plus 3 multiplied by 4x is 12x. Plus 3 multiplied by 2x is 6x. The next thing I can collect like terms. I'm saying 18x plus 12x plus 6x minus 24, and that's equal to 18x plus 12x, that's 30x. 30x plus 6x, that's 36x minus 24, and that becomes the answer to that question. So this is how you solve differential equation using the product rule. The next rule, which is number 5, is going to be the quotient rule. Quotient simply means when two functions are dividing themselves. For example, you have a function. You say, for example, you have a function as this. The two functions are dividing themselves. The best approach to use is v u over the x minus u the v over the x over v squared. Again, I'm going to teach you how to memorize this very one for quotient rule. Notice the difference between quotient rule and product rule. Take a look at this again. There's a slight difference. Okay, why for the product rule we have an addition sign. Okay, we have an addition sign. Why for the quotient rule there's a subtraction sign. So for the product rule, for the quotient rule, there's a subtraction sign in between. So this is how I tell my students to always remember this. In the English language alphabets, V comes after U. All right, just like we want to say in the numbers 1, 2, 3, 4, 5. Let's call this U, V, W, X. Let's call this T, T, U, V, W, X. Okay, so we could see that U comes before V, and v here has a bigger number. This is just an illustration how I teach students to remember this. So if you want to say 2 minus 3, the answer is -1. But 3 minus 2 is 1. And here in this case, our 2 is u, our v is 3. So if you want to use u first if you're writing this as saying u and then the v over the x, subtracting v du over. Now notice this will also remain the same. So if you have v here, you cannot have the v here again. You must have du. That's established. If you use this, that means you're saying u, a smaller number here, which is 2, is subtracting v, a bigger number, and you always have a negative sign. So for me not to have that negative sign, why not say v 3 minus 2, which is v minus u? So that's why this is wrong, this is correct. So that's why we say v will come first, minus u comes second. And then if we know that there is a v here, definitely this must be du. It can't be the v again. We can't have v and v on the same side. And if this is u, we must have the v here. And this will give you over the v square. Don't forget to put the v square. So that's how I teach students how to differentiate between the product rule and the quotient rule so that you don't mix it up. I believe with this example, this illustration I've just given, you won't forget the quotient rule ever again, and it's not going to confuse you ever again. So moving forward, we're just going to solve a little question, a very simple question, very simple question to explain the quotient rule. All right, so we have the question. Let's put up a question on the board using the quotient rule. Example, you have this question on the board that says we should differentiate this x squared over x plus 1. Now you can see this is a question where our u is equal to x squared and our v this is going to be v over u, and our v is equal to x plus 1. So our u comes first. U is always up. The first one is u, and the second is a v. Okay, so the same way we've been doing this, we just have to plug this into the quotient rule equation. So if we know our u, we need to find our du over the x, which is just going to give us 2x. And then we need to find the v over the x, which is just going to be 1. That means what I'm just doing here, I just need to just show you again how I got 1. Differentiating x simply means 1 times x to the power of 1 minus 1. Because x simply means there is x raised to the power of 1. I mean, if there's no power, there is an invisible 1. So that's going to be 1 times x to the power of 1 minus 1. And this 1 times x to the power of 0. And this is 1 times anything raised to the power of 0 is what? 1. So this is now 1 times 1 is equal to 1. Right? So differentiating x is 1 plus differentiating the constant is 0. So that was how I was able to arrive at saying that the v over the x is equal to 1. Okay, if we have that, our question is 95% solved. So I'll just plug that into the equation, and this is going to give me d over dx into u over v is equal to, what's our v? Our v is x plus 1. What's our du over the x? Our du over the x is 2x minus, what's our u? Our u is x to the power of 2. And what's the v over the x? The v over the x is 1. All into v squared. What's our v squared? What's our v? Our v is x plus 1 all squared. Okay, with this, we just need to just do simplification. Just simplify this. We have simplified that. We have 2x multiplied by, we're just opening the brackets. So 2x multiplied by x is 2x squared plus 2x multiplied by 1 is 2x minus x squared multiplied by 1 is x squared over x plus 1 squared. And then here we can collect like terms. We can say, we can still rewrite this. Collecting like terms, we can say this is 2x squared minus x squared plus 2x over x plus 1 squared. And if we collect the like terms there, we're going to have x squared, 2x squared minus x squared is x squared plus 2x over x plus 1 squared. And that becomes our final answer. So you could see how quotient rule is pretty much like product rule. Just know the difference in their formulas and just know their parameters, know which function is for which function, know the right functions to differentiate, and then plug them into the formula. Taught you how to recall this formula and not ever forget them any time, any day you're called upon. So having this in mind, you can be able to solve any differential equation that comes in the form of a quotient rule. Move on to the next rule of differentiation, which is called the chain rule. Okay, the chain rule is pretty just when a function is inside another function. That's when you use the chain rule. When you have a function that is inside another function. So when a function is inside another function. You use the chain rule. What does this mean when a function is inside another function? When a function is inside another function, for example, you have d over dx, then you have a function f, g of x. So f is a function. This simply means f of x, and it's inside a function g of x. When a function is inside another function, these are two functions. G of x is inside f of, it's different from product rule. Okay, this does not mean they are products of each other. This simply means that the g of x, a function, is situated inside the function f of x, not f of x is multiplying g of x. Okay, that's the difference. So chain rule is when the function is inside another function. That's when you apply the chain rule. And to simplify this just simply means the function, you differentiate the function first, g of x, f prime g of x multiplied by g prime of x. Let's put that into a question and see what it means. So example, you have a question that says you should differentiate. I have a question that says you should differentiate. You have 3x minus 2 to the power of 5. So to differentiate that equation, the first thing I need to do is okay, so we have the inner function, we have the outer function. Okay, so I can call this my inner function, my outer function. I can call this my outer function. I can call my outer function. But before that, I can just say let u is equal to 3x minus 5. Okay, then I can say my outer function is equal to u to the power of 5, and then my inner function is equal to 3x minus 2. So having this, I can then say that if I differentiate my inner function, my outer function, if I differentiate my outer function, that's I have to differentiate the u with respect to the x. This is going to say 5u to the power of 4. And you still remember what u is? This is saying that this is also saying 5 into what are u? 3x minus 5 to the power of 4. Take note of this. I'll come back to this. Take note of this guy. I'm going to come back to... Oh, sorry, this was 2, not 5. From the question, that's 2. So I'm going to, sorry for that oversight. So this is going to be 2, not 5, because from the question we have that's 2. Okay, and then let's look at the inner function. So if we differentiate this inner function, differentiate the inner function 3x minus 2, that's just going to give us 3 minus 0, which is the same thing as 3. So now we can now use the product rule to now combine the both of them. We'll combine this function and this function. So if we use the product rule to combine the both of them, that becomes, thus we multiply the both of them. Okay, we just multiply the both functions we have, derived. So that's going to give you 5 multiplied by 3x minus 2 to the power of 4 multiplied by 3. And that's going to give you 15. It's going to be 15 into 3x minus 2 to the power of 4. So what I just did, I just went through a very long process. Okay, the process I just went through is pretty much of a long process. But what this is just saying is, just know the function f of 1, g multiplied by g of x. So you can see that this g of x here is the outer function. Sorry, g of x here is the inner function, and the f here is the outer function. So I'll differentiate the I'll differentiate the outer function, which is just what I did. Our outer function, I differentiated it and I got this, which was this. And then you multiply it by g of x. That's you also differentiating, multiplying by g of x. Multiply by, you differentiate g of x again, and then you get this as your final answer. Right, so let's move to the last one I have today for you, the seventh rule of differentiation, which is called the logarithmic differentiation. So this rule is used when functions are raised to complicated powers that look a little bit complicated. It's also used when several functions are multiplied together, and it's also used when the variable appears in both the base and exponents. That's when the variable appears both in the base and exponent. This is the base x, and the variable appears both in the base and the exponents. So you have something like this, x to the power of x. You use the logarithmic differentiation to differentiate such questions. Let's look at an example and see how we can solve a question like that. So example, we're asked to differentiate. For example, we are asked to differentiate y is equal to x to the power of x. So to differentiate this question, this is a question where we have to apply this rule. You can see that this is when the variable is appearing both in the base. You can see the base here is x, and that same variable is appearing in the power, in the exponent. You can also see it appearing there. So this tells me that I'm going to use this rule of differentiation. So to solve this is pretty simple and straightforward. The first thing we need to do is to take the natural log of both sides. So take the natural log of both sides. Sorry, this is log and not law. Natural log of both sides. So if we take the natural log of both sides, I'm taking the left hand side and the right hand side. This is going to be, if we take the natural log of y, that's going to be ln y is equal to take the natural log of x to the power of x, that's going to be x ln x. So recall one of the standards of differentiation. We have several standards of differentiation, and one of that standard is saying that if you have ln x is equal to 1 over x, we have x to the power of n, which is the power function, is n x n minus 1, and so on. So the same vein, ln y is equal to 1 over y. So that means if I differentiate, we can call this equation 1. So if I differentiate equation 1, I'm going to have this. I want to differentiate the left hand side, and I also want to differentiate the right hand side. Okay, if you don't know how I got this is equation 2. If you don't know how I got this, there is a video I've made solving this very question. I solved it in a separate video on its own, so you're gonna watch that video. Just look somewhere up right there You're going to see the link to the video. Just click it and then you're going to see I explained it in detail, every step, how I got every single value. I explained it step by step, so you can watch that video to get a better understanding of this example I'm solving now. So if I have that, I can call that equation 2. I can say this is equal to, if you differentiate lane y from that standard, that's 1 over y over the x, which is equal to x multiplied by 1 over 2. Sorry, that's going to be 1 over x plus lane x multiplied by 1. So that's pretty simple. You can see this is x. Differentiating lane x, that's 1 over x. This is also lane x. Differentiating x is 1. Pretty straightforward. The next thing I need to do, I need to say that my 1 over y, 1 over y, the y over the x is equal to 1 plus lane x. How did I get that? This x here is going to cancel this x. That's going to be 1. So you left 1 plus 1 multiplied by lane x is lane x. Alright, so that was how I got that. And that's going to give you that you have, moving forward, you're going to have y over the x is equal to y 1 plus lane x. And this is going to give you that the y over the x is equal to right. So that's just how you can solve such a question. So a real recap of what we've learned: the rules of differentiation, we've learned the power function, we've also learned using the we started by learning the power function, and then from the power function we moved, solved some pretty cool examples, and those examples I believe were easy and straightforward. And then we'll move to the scalar multiple rule, where you bring out the constant and use it to multiply function after differentiating it. And then we'll move to the addition and subtraction rule, where you also apply that differential method. And then we'll move to the next one. We solved some pretty examples, and then we'll move to product rule, and this is the formula, so to say, to use to solve the product rule. We solve some examples, and then we'll move to the quotient rule, and we solve some examples. And then we'll also move to the chain rule, solving some examples, and then the logarithmic differential rule, where we also solved some pretty cool examples. So if you're not familiar with any of these rules, just need to go over them again, master them, and know these rules, because they're very, very important. These are the rules you apply when solving differential equation. If you don't know these rules, solving differential equation is going to be very difficult for you. So take your time, go over this video again and watch it, and if you don't understand, you can put comments in the comment section and I'm going to give you a reply to your question. And if you have any question using any of these rules you find difficult to solve, you can put it in the comment box, and if I go through those questions, I'll pick some questions and I'm going to make another video explaining those questions. So click the subscribe button, hit the notification bell so that you're going to be the first to get a notification, be among the first to get a notification whenever I drop a new video, because every day I'm dropping new videos. Drop new videos teaching A-level mathematics and teaching physics and university level mathematics. So every day I drop new videos. So subscribe to this channel, show me some love, show me some appreciation for putting in the work, explaining this. You can't see this anywhere on YouTube, explaining videos like this step by step. So show me some love by subscribing and hitting the like button, and also drop your comments and I'm going to answer all your questions. See you in the next video. Bye for now.